in example 5, we've got the capacitor. It's got 800 volts on it, and then it's discharged through a 25 kilo ohm resistor. We want to know the total energy that's lost. Well, really all of the energy that's lost. So we look at all the energy that's there, and however much energy is in the capacitor, that's how much is lost due to Joule heating. And so my formula, what do I know? I know capacitance and I know voltage. So I can put this in terms of the capacitance and voltage, then I'm good. So it's 1/2 CV squared, right? And so I just plug in my numbers here. So C is 5 microfarads, and the voltage is 800 volts. Square that. I think you get 1.6 joules. Right? That's how much is lost. For example 6, we've got the voltage on the capacitor and the voltage on the resistor both on the same graph. And really this should meet halfway. This should be 0.5 of the EMF. So it's a little off. I'm not a great artist. So we're looking for the place here where when VC is equal to VR, right? The voltage on the capacitor is equal to the voltage on the resistor. Well, this is something that's increasing. So this is EMF times 1 minus e to the negative t over tau equal to, when the EMF on the resistor, that's the EMF, this is decreasing, so e to the negative t over tau. Right? So this cancels out. I'm left with 1 minus e to the negative t over tau equals negative, or e to the negative t over tau. So I get 1 equals 2 e to the negative t over tau, because I add that to the other side. So 1/2 is e to the negative t over tau. So I'm just going to get this in terms of tau. Right? So it's going to be negative tau times the natural log of 1/2 is t. So it's going to be something like 0.693 tau. All right, so 0.693 times the time constant, that's the time at which VR is equal to VC. And that's it for day 1.